Hi everyone, I'm Yasser Ali and welcome back to my channel. In our last video, we explored mesh topology, star topology and bus topology. But today we are going to talk about another simple, old and very important type which is known as ring topology. Remember, this is the final category in the list of topologies. In this video, we will try to cover what is ring topology, what are the types of ring topology, its structure, how does it work, its advantages, and finally we will come to its disadvantages. So make sure to watch till the end to understand everything clearly. And if you enjoy learning with us, don't forget to like the video, subscribe to the channel and hit the bell icon so you don't miss any future videos. Let's get started now. As previously mentioned that the network topologies can be divided into four main categories according to the textbook. These are mesh, star, bus and ring. We have already discussed the three types. Today we are going to discuss the last type of topology, which is the ring topology. In this segment, we are going to learn about the ring topology. Ring topology is a network architecture in which each device or node is connected to exactly two other devices, resulting in a circular channel for data to travel. Data travels in a ring either unidirectionally or bidirectionally, depending on the type of ring structure. The most crucial element is that each device has exactly two neighbors, with the final device connecting back to the first to complete the ring. The data travels in the ring until it reaches the intended device or computer. Let's understand it with the real-life analogy. Imagine a group of people sitting in a circle. When a person wants to send a message, they whisper it to the person on their left. The message travels around the circle person by person until it reaches the intended recipient. This is how data works in the ring topology. The ring topology was commonly used in the token ring network, which is an old IBM networking standard. It was also used by fiber distributed data interface systems. This topology is useful in an environment where data is predictable and orderly communication is required. In this segment, we are going to learn about the structure of ring topology. A ring topology is constructed in a circular shape with each device connected to exactly two other devices to form a closed loop or ring. This design allows data to flow smoothly from one device to the next in specific direction, like clockwise or anti-clockwise. Each computer, server or device is connected to the two neighboring devices using network cable like coaxial cable, twisted pair cable or optical fiber. These connections form a circle where there is no central hub or controlling device. The last device is connected back to the first to complete the ring structure. If you have four devices, for example A, B, C and D, then they can be connected like this. Now we are going to learn about the types of ring topology. The ring topology comes in two different categories. The first one is called unidirectional ring topology, while the second type is called bidirectional ring topology. In unidirectional ring topology, the data flows in one direction only, either clockwise or anti-clockwise. It is very simple and cheaper, but if a particular device fails, then it can break the entire communication path. While in bidirectional topology, the data can travel in both directions. It offers redundancy, which means that if one path fails, then the data can take another direction. This type of topology is more reliable but slightly more complex. In this segment, we are going to learn about the working of ring topology. In ring topology, the data travels in circular path, moving from one device to the next until it reaches its destination. This flow happens in a sequential and organized way, making the working quite predictable. Suppose computer A wants to send message to computer B. Initially, the data is wrapped in a frame or token. In many ring networks, especially token ring, a special signal called token is used. The device can only send data when it has the token, which is preventing the data collisions in the network. The data passes from a device to the next, which is B. If the message is not intended for device B, it passes the frame to device C. As soon the C device receives the message, then it forwards it to the D, and D after receiving the message accepts it. In this communication, each device checks the destination address. If it is not intended recipient, the device forwards it to the next node. The token is then released back into the ring, allowing another device to send the data. We are going to understand the different advantages of ring topology. Ring topology has several useful benefits, especially in the environment where data moves in an organized fashion. Let's understand the advantages based on key features. The first one is high performance in increasing load. In ring topology, the data flows in one direction or in both in case of the dual ring, which helps avoid the data collision. Each device passes data along smoothly, so the system works efficiently when the traffic is too heavy. Since only one device sends data at a time, often using a token, there is no signal confusion or mix-up. The second advantage is about no central controlling is required. It means, unlike star topology that needs a central hub or switch, ring topology does not depend on any central controller. This makes the network less expensive and reduces the single point of failure caused by a hub going down. Each device in the ring plays an equal role, which supports the distributed communication. The third advantage is about adding new device does not affect the performance. It means in a ring network, adding more devices does not greatly impact the speed or the performance, as long as the token passing the system is maintained properly. The ring grows steadily by inserting a new device between two existing devices. Contrasting the bus topology, where more devices can slow down the performance, ring maintains a balanced data flow. The fourth advantage is about equal access to the network resources. Every device in the ring topology gets an equal chance to communicate. Thanks to the token passing mechanism, no single device can dominate the entire network. This keeps the ring fair and prevents network hogging, particularly in shared communication like computer labs and offices. Finally, we are going to discuss the different disadvantages of ring topology. While ring topology has its strength, but it also comes with several limitations that make it less suitable in some modern network environments. Here is the breakdown based on the key points. The first one is slower compared to other topologies. In a ring, data has to pass through each device to reach its destination. This hub-by-hub transfer can make the data transmission slower than other topologies like star, where data goes directly through the central hub. Especially in the larger ring, the delay increases as more devices are added. The second disadvantage is about a single failure can affect the entire network. In unidirectional ring, if one device or the main cable fails, the entire network breaks. Since data travels in one direction, there is no alternate path, meaning all the communication stops suddenly. The third disadvantage is about strong dependency on the main cable. The main cable that connects all the devices in the ring is very crucial. If there is cut, break or fault in that cable, all the devices can lose communication. Unlike bus topology, which uses terminator, ring depends on each segment being intact. The fourth disadvantage of ring topology is it is difficult to troubleshoot. If something goes wrong, finding the faulty device or cable segment can be time consuming. Since the data must pass through every node, or one bad connection or misbehaving system can disrupt the entire communication chain. Troubleshooting tools might not always clearly show where the problem lies. The fifth disadvantage is about adding or removing device disrupt the entire network. In ring topology, when you add or remove a device, the ring gets broken temporarily. This can lead to the network downtime or the need for the manual reconfiguration. Unlike star topology, where device can be added without affecting other devices, the ring requires careful handling. So that's everything you need to know about the ring topology, from its structure and working to its advantages and disadvantages. Ring topology offers well-organized way of communication where every device gets an equal chance to send data. It performs well in small networks and doesn't need central hub to manage traffic. However, it is not without its downside, especially when it comes to troubleshooting, adding new device or handling the network failures. If you are working with a small or fixed network setup and need equal access for all devices, ring topology might be a good fit. But for the large or more dynamic environments, other topologies like star or mesh could be more reliable and faster. If you found this video helpful, don't forget to like this video, subscribe to the channel for more tech explanation, and don't forget to comment if you have any suggestions. Thank you.